So C1 to C3 and the hypoglossal here, you can see, are connected to each other. So there's the C1 component, there's the C2 component, and there's the C3 component. So C1, here it is, C1, C2, and C3, ventral roots, ventral horns, axons coming out of the ventral portion of the cord through the ventral root into the anterior ramus, collect in a net, in a combined piece of information going to the omohyoid, sternohyoid, sternothyroid. So, you can't paralyze one of these guys with a single spinal cord segmental injury. This is a safety net system. We're going to see it become much more sophisticated in the brachial plexus than this. But this is your introduction to plexus information. These three muscles, the infrahyoid muscles, getting the ansa cervicalis of the cervical plexus. Now, the last piece of cervical plexus, we want to do this more than once because your eyes are rolling back in your heads a little bit, is the diaphragm. And this is also a good illustration of what we mean by plexus. The diaphragm is fed by the phrenic nerve. And the phrenic nerve is considered to be part of the cervical plexus. It, in fact, receives information from three spinal cord segments as well, C3, C4, and C5. And here you can see the union of these anterior rami, C3, C4, and C5. So what portions of the spinal cord, what ventral horns, where are the lower motor neurons that make you breathe? The lower motor neurons of the spinal cord that make you breathe are in the ventral horn of the spinal cord, section C3. You be okay? Mm-hmm. All right. C3, C4, and C5. So any injury to the spinal cord that does not allow information to get to C3 will prevent the phrenic nerve from delivering information to the diaphragm. Breathing, the motor output to make you breathe, is here in 3, 4, and 5 of the spinal cord. All right, let's do some muscles then. Yeah, talk about these. First on the list is the sternocleidomastoid. Well, let's do this. Let's go back to the first one. Let's don't get in a hurry with this. Here's the first one. Okay, so now, you heard it from me. The ansa cervicalis is C1 to C3, and you heard from me omohyoid, sternohyoid, sternothyroid. And you saw cranial nerve 12 contributing. Okay, so let's look at it now. All right, so the omohyoid and the sternohyoid and the sternothyroid here on this picture say that they get information from C1 to C3, from C1 to C3. And the key tells you this information is in the in the ansa cervicalis. Now you know what that is. And you understand what I'm saying now, right? So the lower motor neuron feeds from C1, C2, C3, feeds the anterior ramus, not the dorsal, but the ventral ramus. And they union, they form a plexus to feed information to these three muscles, the ansa cervicalis. Now I can also say here for segmental branches, so the thyrohyoid here gets a segmental branch. It gets C1 by 12. Now in the picture of the cervical plexus that you just saw, is that possible? You saw it, right? The hypoglossal nerve joins in C1. So this guy gets C1 by 12. The information comes off of the lower motor neuron, ventral horn, at C1. And then joins the fibers from the hypoglossal nerve to go to the thyrohyoid. We would call that part of the segmental branching. Just one piece of the spinal cord there. Here I have geniohyoid. This muscle attached to the hyoid and the mandible. Remember we saw a genioglossus also from the mandible to the tongue. So this one says C1 by 12 as well. Also part of the same story. So the key now should be making more sense to you. In fact, you already know from the last picture what I mean additionally to that by segmental branching. Segmental branching, is that really part of the plexus? It's not really part of the plexus. If I say cervical plexus, what I really mean is the ansa cervicalis and the phrenic nerve. When I say segmental branches, yes, I'm having individual branches come off of the anterior rami. But you can track those segmentally. That's why we call them segmental branches. So this is a segmental branch here. It gets C1 by 12. All right, so this picture should make more sense now that you've seen the cervical plexus picture. You're going to jump in if something's bothering you, yes? Okay. All right, so now, after having done those muscles attached to the hyoid, we're going to move down a little bit and talk about muscles that are attached to the clavicle and the ribs. So in sequence here, I'm just moving down, yes? The digastrix and the mylohyoid, and the geniohyoid, and the omohyoid, and the sternohyoid, and the sternothyroid. So I'm just going to move down the neck now and start picking up the muscles that are a little bit further down. The big one here is the sternocleidomastoid, and it is attached to the manubrium mastoid and the superior nuchal line. This one has multiple attachments. This should say clavicle also. Oops. So sternocleidomastoid, sternum, clavicle, mastoid process. This is the primary connections to the sternocleidomastoid. Now it says it's innervated by 11 and C2 to C3. 11 and C2 and C3. All right, so let's talk about what that means. Cranial nerve 12 we've seen contributing here to the cervical regions, but as it turns out, 11 also contributes to the cervical regions. And so when you do your dissection of the cranial nerves, you should see along the edges of the spinal cord, along the lateral portions of the spinal cord, you should see a nerve that's hanging on to the sides. And at each of the first 4 or 5 segments, you can see that nerve with connectors into the spinal cord. And then if you track that nerve upwards, it goes up through the foramen magnum. That part you heard once before, but I haven't emphasized it. It connects with a piece off of the brainstem, off the medulla, and then turns and comes out through the temporal bone, through the jugular foramen. That is the accessory cranial nerve, cranial 11. And so it has connections, you see. Cranial nerve 11 has connections to cervical spinal cord segments 2 and 3. And so that's what I mean by 11 and 2 and 3. Innervation of the sternocleidomastoid. The scalenes are split up into a couple of groups. You'll be able to see these in your CAT as well. Anterior, middle, and posterior scalenes. And these guys attach to the transverse processes of the cervical bones and to the first 2 ribs. So we're going to see a couple of things on some of these ribs here. The top 2 have scalenes on them, and then 3, 4, and 5 we're going to put the pectoralis minor on them. So these top 2 have scalenes. They go over to the transverse processes. And these also, I didn't even list numbers here, these also get innervation by cervical nerves, segmental branches of cervical nerves, the scalenes. The sternocleidomastoid and the scalenes, these are muscles that you have to find in your CAT as well. All right, now let's turn him around and start down the back. I've come down to the sternum now with the sternocleidomastoid and the scalenes, and now I'm ready to talk about the muscles of the back. Here's how I'm going to do this. As we do the back now, as we work in this upper region of the back and work our way down, I'm going to do the dissection for you superficial to deep. So you guys have already identified the various divisions of the trapezius and the CAT, and I've told most of you in the lab already that the human muscle is listed as a single muscle. Although you can clearly see, because of the direction of the fibers, functionally the trapezius actually works as 3 separate muscles. So the things it can do to the shoulder are dependent upon which part of the traps you're actually using. All right, so let's talk about its attachments and its innervation, and then I'll take it off and we'll look at the muscles deep to it as we go. These are muscles you're dissecting in the lab. The trapezius is attached to the occipital bone, specifically the superior nuchal line and the external occipital protuberance. You don't need to have to memorize that. We're doing it as simple as we can. The occipital bones and the spines of C7 to T12. All right, we need to explain things like this, yes? Explain stuff like this. If the muscle is in fact attached here to the occipital bone, clearly in the picture I can see that it's attached all the way down the cervical and thoracic spines. Why does your book describe its attachments as C7 to T12? Okay, so there's a very important piece of anatomy you need to learn, and we'll see it as we dissect deeper. We'll see this guy on the rhomboid picture. I'll show it to you again. If you were to cut the trapezius off here, you would not be able to peel it away here, and you would get the impression that it is in fact attached to the spines of C1 to C6 when it is not. It is in fact attached to a thick ligamentous band that sits on top of those spinous processes. Let me show it to you. Fast forward here. There it is right there, there it is right there. Okay, so in this picture that we'll come to later on Friday, you can see that there's a muscle attached right here. These are the rhomboids, and they're deep. Can you see how that piece ends right there? This is the spinous process of C7. So as I work my way this way, there's a thick ligamentous band there called the nuchal ligament, N-U-C-H-A-L, that I'll say, more than one occasion. On top of this nuchal ligament, listen carefully, on top of this nuchal ligament is a ligament that extends from the external occipital protuberance, the bony piece right in the middle on the back of the occipital bone, all the way down to the sacrum. And that ligament is called the supraspinous ligament. Back guys know about this thing because any kind of excessive thoracic stretching of the spinal cord, an excessive thoracic stretching of the spinal cord is likely to stretch the supraspinous ligament and cause problems. It runs right along the top of the nuchal ligament, the supraspinous ligament. Okay, so I'm going to teach you some more of those as we go. The supraspinous and nuchal ligament, sometimes it's called the ligamentum nuchae, N-U-C-H-A-E. That's why in this picture right here of the trapezius, you have spines of C7 to 12. This muscle is in fact attached here, but it is fused into the fibers of the nuchal ligament. And the supraspinous ligament sits right on the edge of that, through the cervical regions. It is also attached to the clavicle. Now wait a minute. The clavicle is on the front of the body. So this is where the cat can help you. Is there a piece of trapezius that will help you in the cat to know that there's a clavicular attachment? What does your lab manual call it? It doesn't call it the spinotrapezius, it calls it the clavotrapezius. Yes? Okay, so there's your tip there. It's good to have the cat to remind you of that. It has an anterior attachment on the clavicle. This muscle actually comes across the top of the shoulder to attach to the clavicle. It also attaches to the spine of the scapula and the acromion. Is there anything that would help you in the cat? Remember that there is an acromial attachment to this. You hear it in the name? The acromiotrapezius. Now it gets cranial nerve 11 and C3, C4 innervation. Segmental branching for the trapezius from the cervical plexus. No brachial plexus here, It gets cervical innervation. Is it okay? Are y'all okay now with 11 feeding C3 and C4? C3 and C4 using 11? How would that information? How does the information in the cervical spinal cord get to the trapezius? Does it come off the spinal cord and go directly out to the traps? No. How does it get there? Up through the foramen magnum, joining with the cranial root, down through the jugular foramen to the muscle. Very interesting innervation for this muscle. Now, I shouldn't have made such a big deal about that because it's true. What we just said is true. But you do see some of these segmental branches coming off directly to this muscle as well. So let's look at that on the cervical plexus thing. So notice where I said segmental branches here. I didn't say 11. So you do get 11, that's true. But you also, see it right there? The trapezius? You're also going to get these segmental anterior rami branches coming directly off here. So some of them will feed cranial nerve 11, and other pieces will go directly out to the muscle in a segmental fashion. No ansa cervicalis to the traps. They get segmental branches in cranial nerve 11. All right? Now, we've done several muscle things already today on the front of the neck and the back of the neck. I'm going to be talking a lot about, as we work our way down to the back, I'm going to be talking a lot about the bones. So I want to finish class today reviewing with you very briefly the names on the pieces and parts of the vertebral bones that I will need to use as we begin to attach. I've already run into this because the scalenes are attached to the ribs, which we haven't looked at, no complication there, but they're also attached to the transverse processes of the first 3 cervical bones. So this is going to be a big deal. You're going to have to remember which muscles are attached transverse and which ones are attached to spine. In addition, we will need to learn superficial to deep. So I need to know where on the spine I'm talking about the attachment. So I want to pause here for the next 5 minutes and review with you the vertebral column stuff. Mention a couple clinical things. So first thing is this, the curves. Let's talk curves. The vertebral column is not straight from a lateral view. It should be straight from a posterior view. If you look at the vertebral column posteriorly and there's a bend in it, we call that scoliosis, a lateral bend. If you look at the vertebral column from the lateral side, there are natural curves here. There's an anterior curve in the cervical region, a posterior curve in the thoracic, an anterior curve in the lumbar, and a posterior curve in the sacral. Now we also have clinical terms for curves here that are too much. For example, in an individual that has a dorsally exaggerated thoracic curve, we call that a kyphosis, K-Y-P-H-O-S-I-S. In an individual that has a ventrally exaggerated lumbar curve, we call that a lordosis, and these cause back problems. The curves are natural, but if they're exaggerated, they become clinical. Scoliosis, kyphosis, and lordosis, the top 3 unusual curves in the vertebral column. Now, as you work your way down the vertebral column, you find that the bones have some particular characteristics. Y'all can help me with this, right? What are the characteristics of the cervical bones that distinguish them from the thoracic and lumbar? The first one I'll give you is their bodies are small or non-existent. So C1 doesn't have a body, does it? C2 has a body, but we call it the dens. So the articulation between the atlas and the axis, which is shown here, where the dens articulates in the fovea dentis, is in fact an unusual articulation between vertebral bones. We don't see this anywhere else. It's unique to the cervical vertebral bones. No bodies or small bodies. So C2, the axis, has a body, but it's a dens. Now that articulation is an important one. That articulation between the dens and the fovea dentis, between C1 and C2, turns out is a very clinically important location. And you could probably guess why from what you've learned today. Earlier today I told you that the diaphragm is fed by the phrenic nerve. It gets C3, C4, and C5. And I said this information comes out of the cervical portions of the spinal cord in the lower motor neurons of the ventral horn, anterior horn, front side. Now, if you look at the bone here, you can see at the level of C1, C2 right here, where the bones are, the dens stick out. It sticks up into the fovea dentis. And there's a ligament that holds it in place. There's actually a sophisticated series of ligaments here. A cruciate ligament, a transverse ligament of the dens here, holding this thing in place. We might talk a little bit more about that as the semester wears on. But it's important to mention here, you'll remember it this way. If the transverse ligament of the dens holding this in place is broken by a sudden whiplashing action of the neck, like in a car accident, this dens will press into the vertebral column at the level of C1 and C2. And if it damages the axons there so that you cannot get information from the brain to C3, what happens?
You die.
You die. You stop breathing. You can't get information through. So this is why we have headrests on our car seats, that articulation. Now we also see here on C1, you guys have noticed this in the lab, there's an articulation here with the occipital bone. And then every other bone articulates with the one below it. So the articulation from C1 to the occipital bone, something we call the superior articulating facet, face, the facet, the face of this bone, articulating with the face, the occipital condyle on the skull. How do you tell this facet from the facet that articulates with C2? How would you tell if you were holding an atlas that you were looking at the superior inferior side from the lab? You did this. How would you be able to tell?
One side is skinnier than the other.
It's what?
Is it like skinnier on one side and the other side?
Right, exactly. It's skinnier or it's smaller, right? So this joint, we call it the zygapophyseal joint between the bones, is smaller on the other side. So the inferior facet of the atlas and the superior facet of the axis is a smaller articulation because the condyle on the occipital bone is large. And so it's real easy. You pick up the atlas, I know immediately where the top and the bottom is because that thing is so big. And finally, I have to shut up. I'm not going to finish this because you are not talking to me. It's not my fault. This transverse process of all these cervical bones has a hole in it. That's not true of thoracic or lumbar bones, is it? The transverse foramina here is a hole in it. It's a very important hole because it houses the vertebral arteries. Now, where have you heard that before? It houses the vertebral arteries. I've heard this. I know I've heard this. Blood is going to my brain. And 50% of it passes through the carotid canal of the temporal bone and the internal carotid arteries. Where's the other 50% coming from? It's in these transverse processes. So the vertebrals come off the subclavians and they turn up those transverse processes. And they get to the skull, the vertebrals come off and pass through the foramen magnum up into the brain. So very important articulation. All right, very quickly on Friday, I'm going to finish talking about thoracic and lumbar bones, and then we're going to continue our back dissection. I'm taking the traps off, and we're going to look at the rhomboids. We're going to look at the splenius, and the semispinalis, and the erector spinalis. And we're going to learn the attachments of the muscles of the back. And then we'll flip him over. We'll do the front. And so you will be learning from me the muscles and their innervations that you're putting your hands on in the cat for the next couple of weeks. Lab test October 26th. I will have said it all by then for all the muscles and innervations. Yes?
When's our test in here? I looked at the syllabus and it said, I think the 17th or 18th, but isn't that fall break?
I'll have to look at that again.
I think it starts on
Thought
the
it was the 20th or something.
Okay, so the 19th, okay.
Okay, so maybe I didn't make a mistake.
I thought it was 17th.
I thought it was